The origins of a wood floor are to be found in glorious nature's trees. To understand the entire process of forest wood being turned into a wood floor, one has to understand the tree. Everything in nature is unique and organic. Everything made from a tree is therefore unique too. A tree grows layer by annual layer, roughly in the shape of a cone, wider at the bottom, thinner at the top, and like all life, has a high moisture content. To grow, it needs nutrients such as water and other substances which are transported through veins. Its stems and branches provide housing for animals or parasites. A tree is a living thing, and each and every facet of its unique life cycle determines the aspect of a wood floor. When selecting the ideal trees for felling, not any tree will do. We need the perfect source material for our wood product. Here is where sustainable forest management comes into play. Associations like PEFC, FSC and others are all dedicated to promoting sustainable forest management. Many hands make quality. Developing a high-quality engineered wood floor with grand beauty is only possible through joining forces. Unilin's standards for perfect quality, its drive to be a front-runner in innovative technology, and a 40-year-long expertise in wood and wood processing come together in a perfectly engineered wood floor. 2 production facilities, one in the Czech Republic and one in Malaysia, ensure a perfect manufacturing flow. A new product is born when an idea is developed. The idea may stem from novel or other market trends in fashion or furniture, or simply through a client's request. An idea for a new wood floor needs to be in keeping with all facets of the nature of wood: the species type, the type of grading, the optimum plank width and length, and so on. These considerations all determine which particular type of wood needs to be obtained and from which supplier. By taking samples, trying out several ideas and discussing them with different production experts, final specifications can be made. Often new machines need to be developed in order to produce a wood board with that new effect. Many such machine developments have been carried out in-house thanks to our considerable expertise and creative insights. First runs are then compared as to color, structure and grading to approved sample boards and altered if necessary to obtain pure perfection. Felled tree trunks arrive at the sawmill. From some 10,000 tree species, oak is used predominantly by us as well for indoor wood flooring. At the mill, the different tree trunks are arranged by length to correspond with the desired sizes of the eventual wood boards. As short, thin boards can be obtained from the same source material in greater numbers than wide, long boards can, the latter will of course be more expensive. First, the protective bark is removed, uncovering the lighter and softer sapwood, in other words, the living part of an oak tree. The tree trunk is then sawed in such a way as to obtain a certain surface design for the final wood board. Sawing through the tree's growth rings at different angles, subtly different patterns are produced. Given the fact that a tree's base is wider than its top, sawing through one growth ring twice will often result in joining grains, wild cathedrals, and potentially large color variations. These boards are known as plain sawn wood. Sawing the trunk, however, radially along its center and thus crossing a growth ring only once results in straight grains and little color variation. The ideal boards are selected and non-usable parts within them are indicated and cut out. Assembly of the boards and stacking them according to grading and size then follows. Unilin offers specific grade and size for its new and novel wood floors. Sawing techniques for other tree species are less specific as far as pattern is concerned. Wood for use in our wood flooring is stocked upon entry in our large warehouse. It's mainly outdoors and roofed because of the humid weather conditions. Wood species, size and grading are the grouping criteria for the stocking together of different wood parcels. Upon first entering our warehouse, an initial quality check is performed on all raw material. Wood boards are both visually and manually checked as to knot size and visible defects, and are then stacked onto spacers to allow airflow in between the boards. This improves air drying of the boards as they await further processing. To ensure good stability of the final engineered wood flooring, stable wood needs to be used. Stability is influenced by controlling wood moisture content and varies according to the end use of the wood product. The final steps in the drying process take place in large kiln dry ovens. Wood boards are loaded onto an automated rail system to be inserted into ovens where they remain from 5 days up to 2 weeks. The ovens are heated by means of leftover sawdust and scraps from production, this being part and parcel of sustainable production as well. We thus recycle waste products to create our energy. In our production plant in the Czech Republic, wood briquettes are made from scrap wood. The leftover scraps are pressed together using steam and come out of the machine in cylindrical wood briquettes. This process is one of the cornerstones of the Unilin approach to ecological waste handling. Keeping wood moisture content in check is at the heart of processing wood. Master that and perfect quality is within reach. That's why we invest so much time and energy in drying our wood in-house. It enables us to produce an extremely stable wood floor board. Moisture content is checked with calibrated measuring tools at different moments during the production process. It's this additional quality check, together with our in-house drying capability, that allow perfect control and which sets us apart from our competitors. The production process of our wide planks starts as fresh green lumber is cut into planks at the sawmill. While still wet, the planks are planed to give them a perfectly flat surface. A 5-headed bandsaw then cuts the planks into 5 or 6 face lamellas, depending on their required thickness. The face lamellas are stacked on spacers and then dried in kilns to the appropriate moisture level for interior use, which is about 6 to 8%. After drying, the lamellas are checked and sorted according to their quality. Once packed, they're sent to one of our production plants, where they're further cut to size. In our Malaysian plant, the saw frame cuts the boards for large lamellas into thinner ones, which will be used for the top layer of our wood flooring. The thickness of these lamellas is checked and the top layers are sorted according to thickness to avoid delamination. Some 5 to 7 lamellas can be obtained from one board, depending on the required thickness of the top layer and the thickness of the original board. These thicknesses do, of course, include tolerances and extras so as to arrive at a final preset thickness. The wood used in the top layers of our multi-strip products is kiln dried before processing. The wooden blocks are planed and straightened. A circular split saw is used to cut the smaller and narrower pieces into lamellas. These are continually checked for imperfections and size differences. Any piece that doesn't meet the strict requirements is discarded. Just as will be done with the full boards, the lamellas are graded. Due to the lamella's smaller size, specific standards are used. Unilin's proven speed and expertise in these processes are key in guaranteeing a qualitative result. Our engineers are highly skilled at fixing problems instantly. In case of a defect, they intervene on the spot. As our saw frames, blades and profilers are extensively used, it's necessary to renew these from time to time. Accurate results can only be guaranteed in this way. As this is carried out in-house, time loss and costs are limited and quality control is increased. These actions require not only the right tooling, but experienced personnel as well. But the investment is worth it. To give our customers a decent idea of what their floor will look like, we set up a unique grading system. Individual planks are thus sorted into different categories. A quarter sawn board produces mostly lamellas with a straight grain, little color variation and no or few small knots. These boards often show what we call mirrors. A next grade may have more natural graining, more knots and visible sapwood. This is the lighter colored and living part of the trunk's exterior. Boards with a more rustic grade possess a wide grain design, a large amount of knots and may show sapwood. These planks derive mainly from plain sawn boards. Through year-long expertise and knowledge, our people are able to grade oak planks within seconds and provide top-quality wood flooring. Using an auto-composing machine, multi-stripped lamellas are combined into a full top layer. Predefined programs ensure sufficient pattern variations, combining the different lamella sizes and minimizing short pieces at the ends of the top layer. All lamellas are glued on 4 sides to ensure perfect adhesion. After pressing, the top layers are checked meticulously. If necessary, any fault or defect is repaired before the panels are cleared for further processing. Next, the core of our wood flooring is made, for which different materials may be used. For most of our products, we use locally sourced heavier or spruce, depending on the location of our production plant. Wood blocks entering the factory are roughly cut to size, with additional cutting performed to the correct thickness. The blocks are then arranged in line and pressed together with a glue strip to create the core mat. They're cut to the desired length, receive a final check for dimension, and are wrapped before storage. Wrapping ensures that moisture content stays within limits. As a last step, we add a strip of HDF to the core mat ends to later on be able to create a perfect click profile. Whether HDF, spruce or heavier wood is used, stability of our final engineered wood floors is assured through in-house control of production, drying and cutting. Only this process guarantees top quality. Before pressing, glue is applied to the core mat and veneer is added. A sandwich-like structure of 3 layers is the result. The veneer as backer, the core mat in spruce, heavier or HDF, and the finally added top layer after glue has been applied. Note that the spruce and heavier blocks are positioned at right angles to the top layers and veneer's wood grain. This setup makes for a reduction of stress buildup in the plank. The hot press hardens the glue with the precise amount of high pressure and temperature to join the 3 layers of an engineered wood flooring board together. This high-tech piece of machinery maximizes quality and press efficiency, as it allows pressing together several sandwiched layers. Process, equipment and parameter control of pressing are crucial in this production step, ensuring highly stable floorboards. After pressing, the boards are conditioned for 24 hours and then checked for defects, stains and adhesion. A sample is taken and adhesion of all layers, including the top layer to the core mat, is tested. Different test methods at different times are performed to avoid delamination. At any time during the process, material and half-finished products may need to be stored. This may be at entry after rough milling or pressing, or as a finalized product. At all times, however, it's essential that the moisture level of the wood in storage is stabilized and doesn't increase. Our wood stock is stacked onto spacers to improve airflow and often protected against the elements by being wrapped in foil. We have special rooms closed to outside air which guarantee a conditioned atmosphere as to temperature and humidity. As moisture level is capable of adversely influencing quality, it needs to be monitored constantly by our experts to safeguard the stability of our products. Depending on the location of our plant and/or the season, ambient air is dried or humidified to create the perfect atmosphere. Remains of tree branches form the knots in a wood plank. These often fall out of the top layer or have cracks inside them. To avoid these and obtain a perfect surface, the gaps are filled with a knot filler. Depending on the look required, the filling's color and depth may vary. Final sanding of the surfaces allow the preset thickness of the board to be reached. Sanding both bottom and top and calibrating the machine led to an eventual top layer thickness within required tolerances. Plank surface is checked for defects to determine whether the planks are ready for finishing. If necessary, knot filling or resanding may be carried out again, or substandard planks are discarded. Any effect of color or structure is done now before finishing. Wire brushing the surface of the wood is performed to accentuate the graining and natural aspect of our wood flooring. This involves brushing the unfinished wood planks by means of metal wire brushes. This scrapes out the softer parts of the grain of the wood whilst leaving the harder parts untouched. Wood species such as oak or ash are most suited for this type of brushing. A vast array of colors can be obtained with oak and other wood species. Color may arise by having a stain sprayed directly onto the wood plank, which then acts like a sort of paint or which reacts with the wood and changes color. You can also fume oak, a process in which tannins in the oak react with the ammonia vapor in a fuming chamber. This technique darkens oak's natural color to a rich brown. Depending on duration, tannin content and temperature color will vary. This process needs to be performed under the most strictly controlled circumstances as to temperature and pressure for safety purposes. Oak with high amounts of tannin react more readily to the ammonia vapor, and the planks turn very dark when left in the fuming chamber for longer periods. Because of this reactive variation, the fuming of oak results in many color variations, not only in the final planks, but even within one plank itself. For every product type, master color panels are kept. During the coloring and finishing of each production batch, we compare the boards with these master panels in a specifically designed color matching room. If needed, the stain is adjusted to obtain a coherent result across different batches and even across both production sites. The composed planks start on their finishing cycle. 7 layers of sealer and lacquer or 2 layers of oil are applied to provide the wood flooring with adequate protection against scratches, stains and dirt. These layers are applied in different stages. Coatings, which may contain pigments for coloured surfaces, are applied indirectly by silicone rolls to maximise distribution. A whitewashed effect, for example, is obtained by applying a coloured stain, in this case a white one, onto a brushed surface. Because of grain depth, the white patina remains after light surface sanding, and a beautifully distinct effect is the result. Every layer is dried in between application, either by air or UV light, depending on the product. The top layer is always UV cured. This hardening technique ensures instantaneous drying, absence of smell, and maximum protection. Applying several thin layers of coating is to be preferred to one thick layer. Compare it to painting walls. A primer with a top coat gives a better result than one thick paint layer. In their continuous run through the finishing cycle, all planks are checked for defaults, dust, and other abnormalities. Each finished plank receives a final check on several aspects. The gloss level of the final lacquer or oil finish is measured. Varying from a very matte oil to a high gloss lacquer finish, this value must be within preset limits. Adhesion and resistance of the final layer is tested in several ways as well. Adhesion is checked with a multi-blade cutter and standardized tape. A chessboard pattern is cut, piercing the varnish film. If the pattern transfers neatly onto the tape, adhesion is said to be perfect. If bits of the varnish coating come away, however, there's something wrong with coating adhesion. A coin test checks resistance against scratches. Resistance to deep scratches is tested with the Hamburger planer. This is a piece of metal which is pushed across the finished surface at a set pressure. The force needed to produce scratches may not go below a certain minimum. Finally, every plank is checked for defects and, if necessary, rerun through the finishing line or discarded. Our lab also carries out random tests after production. The Tabor test assesses resistance of the finish and durability. Standardized equipment is used during and after production to guarantee the quality of the end product. A stain test uses liquids mimicking possible stains at home and highlights the efficient chemical resistance of the protective finish. Unilin is well known for its click system. This uni-click technique originated in laminate flooring and cannot be absent in the manufacturing of a product carrying the name Unilin. Our engineered wood flooring consists of 2 different profiles. This system allows you to install or reinstall your wood floor quickly and easily in any situation. It also makes for strong and jointless floorboard connection. Perfect quality is obtained by grinding the top part of the profile before finishing. Consequently, a coating is also applied in the bevel. Checking profile shape and tolerance is also essential to ensure a smooth click action and perfect alignment. After finishing, the Uni-Click profile is applied onto the plank's long edge. Paraffin, a sort of wax, is administered to the profile's top and bottom to ease clicking and avoid cracking. Tracking information is printed onto the plank to optimize full traceability of the batch. The L-shaped machinery setup enables grinding of both the long edge and the short end profile in one continuous go. Building up the multi-fit profile is done in subsequent steps. two different materials, one hard and one flexible, are co-extruded to produce the locking system. Inserting this co-extrusion into the profile is the final step in the creation of a wood floor. Our final board is inspected with care. Profiles, wax application and profile strength is put to a final test. Profile strength may be as high as 1200 kilograms per meter of pulling power, ensuring that open joints are impossible. A total of 4 different shape sections are projected so as to match the master shape. If tolerances are not met, the profilers need to be renewed. A small floorboard area is installed and tested for different aspects using specific tools. We start off with click smoothness and precision by measuring the height differences between two adjoining planks. Dimensions of each part of both profile and bevel are monitored and data is sent to the SPC, the Statistical Process Control Program. We can thus monitor dimensional statistics, these being the key to ensure constant grinding accuracy. The statistics can also be used to indicate machinery problems, track back the fluctuations, thereby optimizing quality control. Six finalized planks are stacked facing each other. Cardboard packaging with brand communication and a label with detailed product information is wrapped around them. A beautifully designed inlay provides all technical information. The complete package is secured by straps and protected with shrink foil. The latter ensures that moisture levels stay within limits during transport. After packaging, a box is taken out and checked regularly for all relevant quality aspects. If approved, the auditor labels the pallet with a green sticker, marking check date and his name. This guarantees complete traceability of finished products, so look out for this green sticker. A full pallet is stacked and fastened with straps. To protect all box parts, sturdy edge and top cardboard protection is added. To ensure stability and keep out bugs, the entire pallet is finally wrapped in foil. The wrapped pallets are stacked into a container or loaded onto a truck, depending on their origin and final destination.